In the early days of AI, spanning from the 1950s to the 1980s, the first attempts at creating artificial intelligence involved rule-based systems. These systems followed manually coded rules to operate. A notable example from this era is ELIZA, a chatbot developed in 1966. ELIZA used simple pattern matching to simulate human conversation. However, these systems had significant limitations. They couldn't learn from data or understand context like humans do. Moving into the 1990s and 2000s, there was a significant shift in AI from rule-based approaches to machine learning. In this era, models began to learn from data. Several techniques were introduced during this period. For instance, n-grams, which are simple probabilistic models used for predicting the next word. Hidden Markov models, or HMMs, became popular for speech recognition and text processing. Additionally, support vector machines and decision trees were employed in NLP tasks like spam detection. Despite these advancements, these models still had their limitations, relying heavily on feature engineering and requiring extensive manual work. In the 2010s, the landscape of AI saw a revolutionary shift with the rise of deep learning and neural networks. One of the key breakthroughs of this period was Word2Vec, introduced by Google in 2013. This innovation brought about word embeddings, which allowed AI to understand word relationships in a more nuanced way. Recurrent neural networks, or RNs, were also used for sequential data, although they faced challenges like the vanishing gradient problem. Long, short-term memory networks, or LSTMs, improved upon RNNs by remembering longer contexts in text. However, even LSTMs struggled with long-range dependencies in text. Transformer architecture, introduced in 2017, was truly a game-changer. Google unveiled the transformer model in their paper titled "Attention is All You Need." This model was revolutionary because it uses self-attention to understand the entire context of a sentence. Unlike RNNs, which process words sequentially, transformers process words in parallel, making them more scalable and capable of training on huge data sets. The first significant application of this architecture was BERT, introduced by Google in 2018. BERT, being a transformer-based model, was trained on massive text data and became instrumental for search engines. Large language models from 2018 to the present. The transformer architecture really paved the way for these LLMs, which are trained on trillions of words. Some key LLMs over time include GPT-2, released by OpenAI in 2019, which was the first major generative model capable of generating human-like text. Then came GPT-3 in 2020, also by OpenAI, with a staggering 175 billion parameters, revolutionizing AI applications. In 2023, OpenAI introduced GPT-4, an even more powerful model with multimodal capabilities, handling both text and images. Other notable LLMs include Google Gemini, Meta Llama, Anthropic Claude, and DeepSeek, all of which are continuously improving AI capabilities. Step 6. The future, looking beyond LLMs. So, what's next? We have multimodal models, which are AI systems that understand text, images, and audio together, like OpenAI's GPT-4V. Then there's the concept of AGI, or Artificial General Intelligence, which aims to create AI that can perform any cognitive task like a human. Lastly, efficiency improvements are on the horizon, with LLMs becoming smaller, faster, and more energy efficient. Exciting times ahead.